Alright, so today we're going to go over a few of the concepts that we have covered so far in Unit 1, or what we did cover in Unit 1. And we're just going to start off by verbally going over a few of the broader concepts like evolution and mechanisms of evolution really quickly. And then I'm going to bring out a few models or props here in a little bit to help us visualize some of those more complex concepts. So to start is evolution versus mechanisms of evolution. And so in general, evolution is described as the change in allele frequencies in a species or a population over time, and those changes result in branches of those phylogenetic trees that we talked quite a bit about, and everything kind of leads back to a common ancestor. So we're all stem from a common ancestor. It's not like Dr. Husak said. It's not your grandfather turning into your father and your father turning into you. It's all derived. So those other species that did exist still exist for the most part, and the newer species are just have formed from that common ancestor. And as far as mechanisms of evolution, those are the handful of things that cause the change in allele frequency or cause evolution itself. And those are going to be mutation, migration, genetic drift, genetic recombination, sexual selection, so inbreeding or non-random mating, and then natural selection, which is probably the most common one that everyone has heard about, but also probably the most misleading. But to start getting into those more complex concepts, we are going to talk mainly about chordates because even as technical vertebrates like us, we're all still technically chordates, and we're going to try to relate vertebrates and chordates with my models, all tied together through those 5 characteristics that they all share at some point in their lives. So to start, I've got an object here that some of you may not recognize, some of you might. It's something I'm very familiar with. This is my violin bow. So going through those 5 characteristics, I'd say this represents, well, before 5 characteristics, this is going to represent just a chordate. So before pre-vertebrates or some of the more complex vertebrates, this is just going to be a straight up chordate. And I'm going to call it a protosome. If you don't remember, there's 2 classes of chordates. It's the deuterosome or the protosome. We as humans are deuterosome. But I'm going to say this is a protosome because it's just got this one hole here. This is the frog of the bow, but this one hole towards where you hold your hand is going to be the single hole that will represent a characteristic of the protosome. But in general, those chordates are a part of the phylum of Chordata. There's a coelom, which you'll be able to see a lot better in some of the next models, but we're just going to kind of, it's a little bit of a stretch here, but this space between the stick of the bow actually and then the bow hair is going to be like the coelom. So that's like the internal body cavity. It's going to be fluid filled. And so now we're going to start talking about some of those 5 characteristics. The post-anal tail, which is a pretty easy one to remember, we're going to say is the screw of the bow. So this part right here is actually used to tighten and loosen the bow hairs to keep your bow in good working condition. But we're going to say that's the post-anal tail. Then the notochord. So this is actually a really great example of the notochord, similar to what we did in class. And we're going to say the shaft of the bow stick is going to be our notochord here. And if you remember the demonstration that we went over in class, those notochords are really great for support and locomotion. And that's because they're actually rigid. So if you look, I'm trying to compress it here. It's not working, but they're laterally flexible so that you can see this right here. So you can see the bend a little bit. So that's the post-anal tail notochord, and then the dorsal hollow nerve cord is going to be the space between this bow stick and then the bow hair. So let's see. Next, endostyle. It's going to kind of be one of the only structural components that you would see in these chordates, and we're just going to say the endostyle is this frog in general. Endostyle or thyroid endostyle, which evolved first. And then lastly, the pharyngeal slits. Again, this is a little bit of a stretch just because the bow is such a simple object. but if you look, you can actually pull apart the bow hairs there. It's actually horsehair. Fun fact. But you know, those pharyngeal slits are used for a few different things. Some of the most obvious would be for respiration and filtering, but it also is going to allow for filtering of water from food as well. So when they're taking in nutrients, I suppose, those pharyngeal slits help filter out the water from their food and their oxygen as well. All right, just give me 1 second here. I'll grab the next model. So, all right, so we're gonna jump away a little bit from the violin, and we're gonna come to this guy. Obviously, this is a guitar. You guys all know. I don't play this one as well as I play the violin, but this is gonna represent a more complex vertebrae or more complex chordates. So we're getting into the vertebrae now. So if you think about those phylogenetic trees, the vertebrae is going to split off from the chordates, and so the common ancestor here could be a chordate. But this one's going to represent an agnathan, and we're going to go back through those 5 characteristics and a few other ones as well, just on the guitar. So with the post-anal tail is going to be the head of the guitar. So this guy up here, the notochord, so it's going to be that structural component that provides a lot of support for the organism, the chordate or the vertebrae. So here's the notochord. This isn't actually rigid or laterally flexible, but I think you guys are following along. The dorsal hollow nerve cord, which is again a little bit of a stretch on this model, I would say, but I'm gonna say the dorsal hollow nerve cord is going to be the space between the strings and the neck, or the body of the guitar. And then endostyle, we're going to say endostyle is the bridge of the guitar. And obviously you guys know thyroids are really important for secretion of hormones. And then we're going to say the pharyngeal slits are the spaces between the strings. So, like I just said, you know, they're really important for filtering, respiration, feeding, kind of extracting that nutrients that they're going to be able to obtain. Let's see, there's a couple other things about these. Oh, so similar to the first chordate that I said in the bow, this is going to be a better example of seeing that coelom. So you can say the sound hole, the inside of that is going to be the coelom, that cavity. Obviously not fluid filled in this model, but in a real life organism there would be fluid in there. And then this cavity also is going to represent the cranium. So if you remember those 2 major characteristics of vertebrae, kind of the biggest distinguishing factor between just chordates and vertebrates is going to be the full vertebrae, the bony cartilaginous structures that help support the spinal cord even more, and then the cranium, which is going to be that fully encased bony structure for brains as well. So this, like I said, is going to be the agnathan. So we're going to go even a little bit further now down the phylogeny, and we're going to look at a gnathostome. And this gnathostome going to be the violin here. So notice how it's not bigger than the guitar, it's just different. So that's going to kind of be something to think about as well, as these phylogenies are branch off from common ancestors. Adaptations occur and hereditary traits happen, but not all those adaptations are going to be perfect. So if you remember on the guitar, there was the 6 tuning pegs on the head of the guitar. The violin is going to be similar, only with 4 tuning pegs. But an adaptation that you could say is the fine tuning pegs of the violin. So you see these 4 little small knobs right on the tail of the violin, and those are what people primarily use to tune their violin. But like most adaptations, it's not perfect. Sometimes you'll just bump the fine tuning peg, or as your violin expands or contracts with the changing temperatures, the fine tuning pegs can't really affect the string as much, or you know, you may be an octave too low, you might be too flat, too sharp, and so then you have to go back down to the large tuning pegs, which are a lot harder to turn than the tuning pegs on the guitar, and sometimes result in string breaks. So it's a perfect example of adaptations or advancements, you might say, that aren't perfect. But so back through those 5 characteristics of all chordates share. And remember, vertebrates are chordates, so even though it's a vertebrate, pardon me, it's still going to have those 5 characteristics at some point in its life of a technical chordate. Postanal tail, we're going to go with the scroll here. I think it represents a tail pretty well. It's a nice curl. Okay. Notochord, again, we're going to say is the neck of the violin. So this piece right here, the fingerboard, some call it, it gives that structural support. Again, not axially rigid and laterally flexible, but you guys get the idea. Dorsal hollow nerve cord, again, because it's the dorsal, it's going to be on the top, is going to be the space between the strings and the fingerboard running all the way down. Endostyle, again, kind of a similar piece. We're not going to go with the bridge like we did on the guitar, which is this piece of the violin. We're going to go with the tail and the chin rest of the violin as the endostyle. And pharyngeal slits are actually pretty fitting here. Even though it's a PHF, not an FF, these holes in the violin are called F holes, and serves the same purpose, just reverberation of sound. But that is going to act as our pharyngeal slits in this model, and that body cavity again is going to also represent the coelom, so that fluid-filled cavity, and the cranium, and then this tan part of the neck is going to represent the vertebrae as well. It's even kind of got the vertebral spines that allow for muscular attachment and further support for locomotion as those vertebrae transitioned into tetrapods and mammals as they moved out of the water and onto the land. A few other characteristics about the gnathosome. Remember, it's the jawed fish, so that has muscularized jaw, and then with that muscularized jaw, it actually gained the ability for predation. So this is representing predation. And then, if you remember, paired pectoral and pelvic fins. So these little inlets, the S inlet of the violin here, we'll say these are the pectoral fins paired, and then these can be the pelvic fins paired as well. Alright, so I know that these models weren't perfect, but just kind of going back over everything, I know they're a little simplified compared to the actual organisms that we've been studying. Like the endostyler, the thyroid don't actually show the filtering of iodine, don't show the gas exchange, stuff like that. I know there's a lot of duplication of parts used on these models, like for the pharyngeal slits also acting as the cranium or the coelom, stuff like that, or the vertebrae acting also as the notochord. So there's a little bit of overlap, but at the same time that kind of also emphasizes the morphological similarities that these organisms share, like the homology or the convergent evolution of all these things, and so that makes it easy for us to relate those characteristics and those concepts back to the original things of the phylogenetic trees, and how that phylogeny is related to the evolution and the evolutionary mechanisms.